Welcome to the second video on linear relations. In this video, I'm going to be going over how to analyze patterns and some skills that will help you in that area. So let's get started. I've got the first example here. And by the way, when we're analyzing patterns, the idea is figuring out a pattern that's formed from something and using that to be able to predict or figure out what's going to happen if the pattern continues way into the future. So you can see in this example here, we've got four figures that I've drawn with a bunch of squares, and that it keeps getting bigger and bigger. So by the end of this example, the idea is that we're going to be able to quickly figure out, for example, in figure 100, how many squares are going to be used to make up that figure. So a great starting point is to create a table of values. And so in this example, we're going to be comparing the figure number, which starts at 1, goes 2, 3, and 4, so that keeps going up by 1. We're going to be comparing that to the number of squares that are in each figure. So let's create our table of values here. And we're going to put our x values on the left, so we've got figure number 1, 2, 3, and 4. And of course we need to label that, so that's our x. And that is figure number. And then our y value will be the number of squares. And if we count the number of squares in each figure, you can see that it starts with 1, then becomes 5, and then 9, and then 13. So you can see that the amount of squares is increasing by 4 each time. Now that we've got the table of values figured out, we can figure out the relationship in terms of the equation. And we learned how to do this in the previous video. So we remember that it's always y equals something times x plus or minus something. And then to figure out the coefficient in front of our x variable, it is how much the y is increasing or decreasing each time. And as we just figured out, it's increasing by 4, which means our coefficient will be 4. So it starts off as 4x. And then to figure out our constant, again, we just pick one of our x values, actually multiply it by 4. So let's do 2 as an example. 4 times 2 gets me 8. Now I need to think, how do I add or subtract to get to 5? Well, I would have to subtract 3. So it's going to be 4x minus 3. Now the great thing about having this equation is that we can use now to figure out, like that example I gave earlier, if we were trying to figure out how many squares make up figure 100. So let's actually figure that out right now, using this equation to our advantage. Okay, so, oops. So figure 100, we need to figure out how many squares make up that figure. Well, we know that figure 100, we're talking about the figure number, which is represented by our x value. What that means is in this equation, y equals 4x minus 3, what we basically need to do is rewrite the equation, except we're going to replace the variable with 100. And we know we're replacing the x variable because that's what the figure number is represented by. So all I do is instead of x, I'm going to replace it with the number 100, just like this. And it helps to put in brackets because I know that 4 times x is the same thing as 4 times 100 here. Then we've got our minus 3. Now we just do some simple calculations. I know that 4 times 100 is 400, and then I subtract 3 from that, and that would get 397. So I know, using that equation, that figure 100 would have 397 squares. So obviously that's a much faster way of figuring out, instead of actually drawing 100 of those figures. That would be a nightmare. One more type of problem that you'll quite often see is instead of being given the figure number, or the x value, you'll be given the y value, and in this case, that would be represented by the number of squares. So let's say there was a question, which figure number has 77 squares? Okay. Now, we're going to start by rewriting the equation that we figured out. Y equals 4x minus 3. Now this time we're being given the y value because we know the y value represents the number of squares. We know that there's 77 of them. So in this case, we're actually going to replace y with 77. So it's going to become 77 equals 4x minus 3. Now we just need to figure out what's the x value that makes this true. 77 is equal to 4 times something minus 3. Well, this is an algebra type problem where we need to start working backwards to isolate x. So the first thing we do is get rid of the minus 3 or subtraction 3 by adding 3 to both sides of the equation. And we do that because negative 3 and positive 3 cancel each other out. 77 plus 3 gets me 80. So we know that 80 is equal to 4 times x. So 4 times something is equal to 80. To figure that out, all I need to do is divide by 4, which cancels those out. And 80 divided by 4 is 20. So 20 equals x. So that means figure number 20 would have 77 squares. So that's the only example I'm actually going to go over in this video. I hope that it was helpful, and good luck.